Hi students, Miss Walsh here. And what we're going to do today is we are going to take a look at the Pearson's correlation coefficient as well as, so the R value as well as the line of best fit. What I recommend that you do is that you do jot some key points in your notebook, but don't feel that you need to be writing all of this out, okay? You have to be smart about this time. This content is available for you anytime. So just listen and follow along on the calculator. That point is important. So first of all, when we have what correlation means is it means that two variables, so this is two variable statistics, have some sort of an association between each other, okay, with each other. So this implies that there's an absolutely perfect linear relationship. So this is, for example, if you are charged €2 per hour for something, well, as the number of hours go up, for each hour, this will go up by 2, okay? This is a perfect correlation. Other real life variables will have a strong positive association. And by positive, we mean that as one variable increases, the other one increases with it. So the typical school example is perhaps, well, the more hours that you study, the better grades that you get. Perhaps there's an association with that, the grades and the number of hours studying, as opposed to the negative correlation is as one variable increases, the other one decreases. So perhaps the more hours that you put in studying, the less free time you have. So as this goes up, you can see that it causes you to have lower values on the y, okay? So this we call negative correlation. The correlations will always have a strength between -1 and 1. This is important, so you can jot this in your notes, including, because the 1 and -1 has this perfect 100% relationship. And there's lots of variables. This is an extremely weak correlation, and that happens a lot. You can do something like, I don't know, the amount of ice creams you eat per week versus the speed of somebody reading. You're probably not going to get any sort of an association there at all, okay? So I've put more information here for those of you that are new, but you've done this in 9th grade somewhat, so I'm going to skip this to keep the podcast as short as possible, as I always do. Okay, so this is the R value. This is the Spearman's correlation coefficient formula. If you want to, a challenge that I have for you is you can try to do this in Excel. So try to take data, put it as the X values, and then find the mean, and then try to follow this along and see if you can get the same value that the GDC will give us. Alternately, you can also challenge yourself to do this on the spreadsheet on the GDC. Also quite exciting if you can get exactly the same value, okay? A warning word about correlation, and this is one of those warnings before use. If you buy a new product and it tells you under no circumstances put this in a dishwasher or something like this. When you're dealing with correlation, so relationship between two variables, it doesn't mean that one causes the other, okay? So an example that I found here was that, when it's cold in the UK, people are shopping more, okay? So an easy conclusion would maybe come, oh, well, the cold causes people to shop more, where in fact it gets cold in November and December, and this in the UK is coming closer to Christmas time, and of course people tend to go to the malls more, okay? So be very, very careful. If you take a university class on statistics, your professor will likely shout at you that correlation does not mean causation. Another real life example of this was smoking and lung cancer. I realized I could have written this out before. So it took actually decades. So there was clear evidence that there's a correlation between smoking and lung cancer. But to actually prove that smoking does cause lung cancer took literally decades. It's something that we take as natural these days, but this was a very, very long political process with lots of statistical crunching behind it, okay? So please do take that as a warning. So here we go. We're just going to do one example because I don't want this to be too long, and we're going to do this on the calculator, okay? So hopefully you've got your calculator in hand. If you don't, go ahead and grab it. And here we go. So today, the menu that we are going to need is we're going to need two variable statistics. And just a very quick word. In the last couple of days, you were doing chi-square test. Chi-square test, if you noticed, well, this was things like, the income level and smoker or not smoker, or gender, male versus female. So these are qualitative variables, okay? They're non-numerical, as opposed to correlation deals with numerical data. Okay, so here we go. And in the two stats variables, go ahead and enter the data. Just pause the podcast and just make sure that you're in C1 and C2. If you're not, no problem, but just notice that which one you're in, okay? What we're going to do then is we're going to plot this data. Okay, so we've plotted this, and you may have some sort of a line going through this, okay? So if you go to the menu and hit fit, then I've got this line as well. What this line is, so if you go to the symbol, and you may have something different here, this is a regression line. So this is the line of best fit. You may have nothing here, okay? So let's see, can I do something like this? So user defined, see, and now I will have nothing there at all. I don't have any f of x, or it thinks I have some sort of a f of x. But if I go to the linear, and now it's asking me, yep, mx plus b, that's the form that I want. And now if we hit plot, it plots. And then if you go back to the symbol function, then it shows you what the equation is, okay? So here, it's going to ask us later to write the equation of the line of best fit. So we're just gonna go ahead and do that now, okay? So go ahead and write that in your notes with me. And I'm not really going in order, but that doesn't matter. My goodness. Okay, I could perhaps round this to 8. 97.25. Okay, this is the slope. Remember what we're investigating here? We're investigating the height versus the weight, and the slope is the change in the weight per height. So you could say here, I'm assuming this is in pounds actually. Nope, this is in kilos and this is in centimeters. Okay, so then this would mean that per, so change in y over the change in x, so for every extra centimeter, we're gaining about 0.98 of a kilogram. And these are football players, by the way, so it might be a little bit different to regular people, okay? All right, so we need to graph the data. We've done that. Write down the mean height and the mean weight. Okay, we're going to go back to the values, and I just need to restart it because it makes the buttons disappear. Okay, we're gonna go to stats, and what this is right here is this right now is the statistics for the two variables together, okay? Notice there's our R value, there's our correlation coefficient, woohoo. So let's just take a moment and write it down as well. Where's that? It was right here. I'm gonna avoid making a mess, and so our R, since we're rounding, is 0.955. Okay, notice it's positive. So we're going to say positive, and it's very strong. So there's a very strong association between the heights and the weights. Okay, now they want the mean height and weight for each. Notice this is not in the table that we had. But, and again, the way that I got to this was from the numbers, okay? Number and then stats. But notice here, you are offered the statistics per variable separately. So I'm just going to hit the X here. And now I can see that and remember, X bar means weight. We've done that before. So the mean weight here is 175.6. And then the Y bar is, I'm going to go to the Y statistics now, is 72.57. Okay, notice here it's asking you for something that you haven't done. We're not going to do the formula for this before today, but standard deviation is the average distance of values from the mean. Maybe we'll do a lesson on that on another day, okay? So it's how spread out your data is on average, right? You can have the same mean for a set of data, but the spread can be very different. So that is going to be this number right here, okay? So population standard deviation. We're taking this as a population at the moment, and here we go. So, and this, by the way, this right here is a little, this is lower capital sigma, another Greek letter. You've seen this one, right? This is big sigma. This is capital sigma. Okay, so how much does this deviate? Okay, so we're getting 6.71, and let's go back and get the standard deviation of x, and we have this standard deviation of x is approximately, here we are, we're going to go to the sigma again, 6.48. It's interesting, it's almost the same. So look how different their means are, but their standard deviations are actually almost the same. That's cool. Okay, we've got the line of best fit. And so what we want now is we are asked for determine the equation of best fit. We've done this. And so last two bits, and that is of course to get some values out of this. We're going to do this with a calculator, okay? Something cool that I wanted to show you. Okay, so F, we need the weight. So we're going to get this from our table of values, and we're going to use the equation of best fit, okay? So we have our equation of best fit. So enter, and I'm back at these values. And remember, if I go here, there's my equation of best fit. What you're going to do is you're going to use the copy button. So Shift, View, that'll copy it. Boom, it's on my clipboard. And now let's go to the function, and you're going to paste it into, so paste is right here below. You're going to paste it. Yep, press 1 or enter, doesn't matter. And now you've pasted the equation. Now, when you go in the table of values, you're in the function app. Now, this is showing you the calculated values. This is not your raw data from the equation that you have entered. Okay, let's change this. Nobody's interested to going to 180 by 0.1. Ain't nobody got time for that. All right, let's start at, let's say, just for fun, at 150. And let's just go up by 1. And now when you go to back to your table, and I know some of you already know this, some of you are quite handy with the calculators, which is super for the applications, either courses next year. And there it is, okay? So I'm being a little bit lazy and not showing my work, but it's about calculator power, okay? So our weight at 180 looks like it would be 80.9 kilograms, okay? It roughly makes sense. Notice for 183, we would be at 85. Okay, last step. So now it's asking us to determine the height when the weight is 100. So now what we're given is we're given the y value, right? How do we do this? We've done this by intersection. Let's do that. So what we're going to do is we're going to put 100 into the y. Okay, and again, you can use the table and see when, at which point this will actually, at which x value this will also hit 100, but I would like to do it visually. When you plot, it may not show up. Just go to 3 auto scale. It does quite a nice job. Okay. And okay. So if you see that it's not showing up quite nicely, you can try the auto scale of the other one. But if it's not working, we're just going to fix the window manually. So let's go to plot setup. Okay, so what is this? This is way too small because look, our y has to be, oh, so I'm somehow ended up, yeah, it somehow C-plotted me not very well. So we want the y to be showing 100. So I'm going to make the ceiling of 120. And then on the x, this is probably not going to be an adequate height. we need the height to be pretty big. So I'm just going to set it to 200, just roughly. All right, try it. Ah, there it is. Okay, so we're almost there. And now we can just find intersection. Okay, intersect with it. Yep, no problem. And there's our intersection, okay? So the height is almost 2 meters. And notice we were asked for quite a heavy person, right? We were asked for 100 kilos. So it makes sense that our height is going to be pretty big. Okay, so just to summarize, you've got the equation of best fit. And in order for you, we copied and pasted it. That we got in here, the symbol, but you have to be in the two variable statistics mode. We copied and pasted it into the functions. And then from there, you can get the table of values for the function, okay? And then remember that correlation coefficient shows you the strength, positive or negative, but it doesn't mean that one causes the other, okay? All right, thanks, bye.